Hello, this is Sarfraz Niazi, and today I'm coming to you to talk about some of the very basics of where we are with COVID 19. This is for general public, not for scientists, but if you feel that it has some help, please distribute it. First of all, let me share with you what is the virus infection. Virus is not a live body, it's just a piece of genetic material. When it enters our body, there's a fight. There's no truce. Either the virus wins or we win. We win by producing an antibody or a protein that will inactivate the virus. In some cases, the battle is so ferocious in our body that some of the warriors that we produce, called cytokines, end up proving to be more dangerous than the virus itself. So this is a bad battle. How we win it is where we all survive or not survive. This coronavirus happens to be a similar virus to what we had a few years ago, the SARS virus, and we now know a lot about it. In fact, we knew 80% of its construction before it came to become a threat. So it's not that difficult for us to claim that we can make a vaccine or make a solution. But let's take a quick review of what's available out there. First of all, there's drugs, antiviral drugs, and right now there are over 100 drugs available which affect the viruses. One of them, the remdesivir, which was recently allowed by FDA as an emergency treatment for coronavirus or COVID-19. But I must tell you that this is not a treatment. This drug reduces the hospital stay from 11 days to 8 days for those who are about to get healthy anyway. So there is no antiviral drug today, even though there are more than 200 being developed for coronavirus. Today we don't have it. We also have no confidence in the HIV cocktail Kaletra or even hydroxyquinone, chlorohydroxyquinone. So there's no drug out there to treat the virus. Let's get back to what is the solution. The solution is very straightforward. It's a vaccination. Vaccination simply produces enough antibodies to take care of the assault when the virus enters our body. There are several types of vaccines. Right now, by the way, there are over 100 vaccines under development. We can take a virus and make it less effective, or we call attenuated. It's still a live virus. We inject in our body to get the antibodies. Or we can take an inactive virus and inject in our body. The attenuated virus seems to have a much better antibody profile, and it also provides some broader coverage. For example, the older vaccines that are produced using attenuated virus may even have a cross sensitivity to the coronavirus. Okay. The third approach we can take is, instead of using the virus itself, we take the DNA or RNA of the virus, which is the genetic code, and put that in the body and let the body make the protein, which then it will use to make an antibody on its own. Unfortunately, the easiest and the best way to make vaccine has never been approved by FDA for any vaccine. And I'm hoping that as many vaccines that are being developed today for corona will open up a new type of vaccine, which is the DNA or RNA vaccine, with great success. Another approach to treat is, of course, creating a monoclonal antibodies based on the genetic code. And at least I know there are two products being developed as the MABs. In my opinion, if we can be successful in creating a good MAB, that will be one of the easiest and the safest solution to treat COVID-19. So let's come to the testing part of it. Okay, there are only two ways to test the efficacy of a vaccine. One is we give this vaccine to a large population against a placebo who gets nothing but injection of water, and see what percentage of each of the group develops the disease. The problem is it takes a long time, and there's so much variability because this population may or may not get exposed to the virus. The other one is called active testing, in which we give the vaccine to a fixed number of subjects and then intentionally infect them with the virus and then see what was the result. Obviously, you can understand that there is an ethical consideration here. What if the vaccine didn't work? We may have on our hand hundreds and thousands of people who may face the disease in the worst possible form. So we go in a stepwise basis. Okay, we do a small number of subjects, but before we do that, we also test it in animal models like chimpanzees who may show the similar response as humans. The Oxford vaccine, which is a fourth type of vaccine where we take an existing vaccine and modify it. Since the vaccine has already been proven effective and safe, this is the fastest route to getting a vaccine done. So I'm hoping with all these combinations that are in place today, probably I don't think in the last 100 years people have not come together, whether they're academics, industry, or whatever, to find a solution. With 250 drugs, 100 vaccines under development, I'm very optimistic we'll find a solution. And soon, when I say soon, okay, there are a lot of criticism about how long it takes for vaccines to develop. But in the case of this virus, we already know a lot about it. Almost 80% of the structure is known. So if I say that there will be a solution, a vaccine solution, I have a reason to believe that it is possible. Just a word or two about FDA. For those of you who have not worked with FDA as much as I have, for every scientist that's out on the FDA payroll, there are 3 lawyers. The reason is that FDA cannot afford to take any liability. A drug or a vaccine approved that may turn out to be not as effective can take large number of lives. So you gotta give FDA benefit of doubt. You gotta give them a reason to believe that a product is good before they will allow to be used in humans. But I'm sure, with all the wisdom that the FDA has, if they say that the product is good, I want you to believe that it is good. And now I've just a couple comments which are unrelated to the science part of it, okay, but certainly they are in many ways. In 1917, we lost 50 million people to Spanish flu, which will be like losing 200 million people today. But that didn't happen. Along halfway through the crisis, we declared we have won the war, and we came out and lost more people. In today's numbers, it will be like losing 200 million people. So when I see comments like, well, we lose 50, 60,000 people every year from influenza, so what's the big deal? The big deal is, yes, after 50, 60,000 people, influenza goes away until next time around. If you don't control this virus, it can annihilate the entire mankind. This part has not been understood. There are people out there who are saying that this is my Second Amendment right to go out. I would say, yes, absolutely. You have every right to kill yourself, but you don't have the right to kill others. No amendment allows you to do that. I would like us to be a little bit more careful, okay, jumping at the conclusions that we are ready to go out. I am 100% with Dr. Briggs's assessment that we are not ready yet